All right, picking up with our Chapter 4 review, this is problem number 18, and I'm not sure what the question asks us to do, so let me go back and look at the problem on the review. Asks us to find only the rational zeros of this function. So here we're looking at possibilities first. So I'll look at the factors of 44, which are 1, 2, 4, 11, 22, and 44. And so I want to check among these and see if any of these are rational zeros. I know my answer choice is not going to be A because negative 3 is not even a possibility. All the rest of them are possibilities. So I'm going to use my calculator and see if any of these are actual zeros or not. Okay, so in my calculator, I type the function they gave me, and now I want to check to see if there are any rational zeros. So I'm looking for numbers like 1 and negative 1 and 2 and negative 2, 4 and negative 4. None of those appear to be rational zeros. I could check 11 and 22, but those aren't in my choices that they gave me, so my answer is going to be D. There aren't any rational zeros. All right, number 19. Using Descartes' rule of signs from the number of positive real zeros and the possible number of positive real zeros and possible number of negative real zeros for the function. All right, so for the positives, we use the function exactly like it's written. 3x cubed minus 9x squared plus 8x plus 3. We want to see how many times do our signs change from plus to minus. Well, the first one's 3, so that's a positive, and then there's a negative 9, so there's a change. Then it goes from negative 9 to positive 8, so there's another change, and then another positive 3. That's not a change from positive 8 to positive 3. So there's 2 with the positive, and you always count down by 2. So 2 or 0 positive. So I'm thinking this is going to be my answer. It's the only one that has 2 or 0 positive, but just to make sure, let's try f of negative x and see what we get. That didn't do good. F of negative x would be 3 times negative x cubed. Everywhere there's an x, I'm going to put a negative x. And then I'm going to evaluate this and then see how many times the signs change here. So negative x cubed would be negative times 3 would make this negative 3x cubed. Negative x squared would be positive times a negative 9 would be negative. 8 times negative 8 times negative x would be negative 8x and then plus 3. So it starts negative, stays negative, and then changes to positive. There is one change. So 1 negative, 2 or 0 positives. Number 20, find the domain of the rational function. We're looking for domain. We're looking at this bottom. What can x not be? What's going to limit our values? What won't work if we were to plug it in? So set x squared minus 4 equal to 0 and solve that. So you get x squared equals 4, so square root both sides, x equals the positive and negative square root of 4, so x equals positive and negative 2. So that's what x can't be. So if we're looking on a number line, at negative 2 we would have a spot where it wouldn't work, and at positive 2 we'd have a spot where it wouldn't work. So all of this works, and then all of this works, and then all of this works. X just can't be negative 2, and it can't be positive 2. So which one would represent that? D, from negative infinity to negative 2, and then from negative 2 to 2, and then from 2 to infinity would be my domain. My domain here, if you're looking at the bottom, what I'm worried about is that 15 minus x cannot equal to 0. So solve this by subtracting 15, divide by negative 1. X equals 15 will be my value. That won't work. X can't be 15 because it would make the bottom of this fraction 0. So if x can't be 15, then everything except for 15 on this number line will work. So from negative infinity up to 15, and then from 15 to infinity. So my answer is C. Number 22, find the vertical asymptotes of the graph of the given function. A lot like your zeros. The only thing you want to do here is make sure there's not a common factor, and there's not. X plus 7 over x minus 3, no common factor. So set x minus 3 equal to 0 and solve it. X equals 3 is going to be a vertical asymptote. A. 23. Now, this one, before you start, you want to factor it because there can't be any common factors. So the top, x squared plus 3x, has a greatest common factor of x, so it's x times x plus 3 on the top. And on the bottom, X squared minus 5x plus minus 24 factors to x minus 8, x plus 3. Well, these do have a common factor, x plus 3. So cancel that out, and I just get x over x minus 8. So now I can look for my vertical asymptote. I said x minus 8 equals 0, so x equals 8 will be my vertical asymptote. A lot of people mistakenly think it's both 8 and negative 3, and I probably didn't stress that enough in class. But if it is a factor of the numerator, then it would not be an asymptote, according to the definitions. Number 4, find the horizontal asymptote, if any. Okay, so for our horizontal, we got 3 different situations. 1, if the degree of the numerator is less than the degree of the denominator, then y equals 0 is your horizontal asymptote. Or if the degree of the numerator is equal to the degree of the denominator, then y equals a over b will be your horizontal asymptote, where a is the coefficient of the top and b is the coefficient of the bottom. Or if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. So here the degree is 0 on the top and it's 2 on the bottom. So the top degree, numerator, is less than the bottom degree. So it's going to be y is equal to 0 would be my horizontal asymptote. Again, degree of the numerator is smaller than degree of the denominator. So again, it's y equals 0. That's my horizontal asymptote. Here the degree of the numerator is larger because the degree of the numerator is 4. Degree of the numerator is 4. Degree of the denominator is 2. So that's larger than 2, so there would be none. And then problem 27, find the oblique asymptote. There is an oblique asymptote when the degree of the numerator is 1 more. Degree of numerator is 1 more than the denominator. And there is here, because this is 2 and this is 1, so it's 1 more. So then you're going to do synthetic division, so dividing by x minus 3, I'll put a 3 on the outside, or long division, prefer that. And then the coefficients would be 1, 7, and negative 6. So bring down the 1, 3 times 1 is 3, add, you get 10, 3 times 10 is 30, add, you get 24. So this is y equals x plus 10. The remainder is 24. That doesn't even matter here. So this is my oblique asymptote, y equals x plus 10. And 28, it asks to find an oblique asymptote. Well, the top degree is 1, the bottom degree is 2, so there's not going to be an oblique asymptote. The top has to be 1 more than the bottom. 29 asks me to graph this, showing all asymptotes that do not correspond to an axis as dashed lines. List the x and the y intercept. Okay, I'm going to have, if I look at the bottom, x equals 0. So my y-axis is going to be a vertical asymptote. And then the degree of the top and the degree of the bottom are the same. So y equals, it'd be 5 divided by 1 if I look at my coefficient. Y equals 5 is going to be my horizontal asymptote. So it looks like my choice is going to have to be B. That's the only one that has y equals 5 as a horizontal asymptote and x equals 0 as a vertical asymptote. And then when I plug it in, it's not going to ever touch the y-axis because that's an asymptote, so there's not going to be any y-intercepts. And my x-intercept is going to be right down here at negative 1/5. It hits 0. And you can graph it on your calculator to find the 0 there. But my answer would have to be B. And my last question, nope, 29. That is 29. Last question. This function gives the body concentration in parts per million of a certain dosage of medication after time t in hours. Graph the function from 8 to infinity and complete the following. So what I'm going to do is I'm going to look at where is it approaching as we approach infinity. So that means where would my horizontal asymptote be? So it'd be these coefficients, 0.6 divided by 4. Let's see what that is. 0.6 divided by 4. 0.6 divided by 4 would be 0.15. So let's go back over here and check. It approaches 0.15 as t approaches infinity because that's going to be my horizontal asymptote. So my answer here is going to be C because you divide the coefficients of your leading term when they have the same degrees. Degree of this is 1, degree of this is 1, so I'm going to have this line at, it's going to approach 1500ths as t gets bigger and bigger and bigger, because that's going to be my horizontal asymptote. So my answer for the last one is going to be C.